December 8, 2016. As you're looking at the Cascadia fault zone, we're watching the 6.5 Aftershocks. Now, something very strange just happened. It may have been a mistake that they came in and corrected. But first, this 5.0 Aftershock here, guys, came in. And notice the depth, 4.3 kilometers compared to 12.1 with the 6.5. And on that 6.5, by the way, there's reports coming in that the ground rolled and they felt a jolt. Then the ground just rolled. Wasn't a lot of damage, but they said it felt like being on a boat. And that's a strong quake. But just as I was setting up, guys, to screen capture this image, there was a 4.3 right here. Some of you, 4.9 here. And it was back down to about 5.3 kilometers. But by the time I set up the screen capture to make this video, that one was gone. Again, it could have been a correction. But just for the record, it was setting here. It was much closer to land, and it was at 5.3 kilometers of 4.9. It could have been some kind of echo reading from this 5.0. I don't know. But the location was much closer in. And really that prompted me to do the video. But with this 5-point aftershock, look at the difference in the depth. They become very shallow. And it's on top of that ridge, and that may have a lot to do with it. But if it's on top of that ridge, that is the one that's, or the section of the Cascadia fault zone in this lower part that connects directly to the San Andreas fault. As a matter of fact, it's part of the same exact system, guys. So pay attention to this as you look down through Southern California. You've got a small one down in the Baja area, 3.1, but we see that a lot. This is a strong quake. Maybe it was the only strong quake we're going to see in this series of events, but this is not an area to play with, and this is not up in the middle of the Cascadia fault zone. I want you to notice something about the geology here. You've got, again, the North American plate. You've got this a Pacific plate that's pushing under it. And this particular part of the Cascadia area is just a section of this area that broke off. You can see if you pull this up, these high ridge lines, and it's just like a concrete slab that breaks off on one end, or a corner breaks off, guys, and it's going to break back. It's going to push up a section behind the part that's going under the North American continent. And so what we've seen is so much pressure here over millennia. Your section has broken apart, and you have three areas. But again, this section, part of the San Andreas area. Now, in the earlier video, I mentioned this geomagnetic storm watch for December 8th and the 9th, with the wind speeds jumping up to 700 kilometers per second. It's very fast. And in the video, we were in the 500s earlier, so we see an increase in solar wind of almost 100 kilometers per second. Now, the density here at 5.1 has not increased, and we may not see an increase in that. As a matter of fact, I have seen that decrease because the solar wind's going by so fast that it doesn't have the density per cubic centimeter that you would normally have. In other words, it's kind of diluted, just like smoke would be diluted in a high wind. You wouldn't have that thick stream. Same thing happens here. But we are possibly going to see another 55 or so kilometers per second at if it goes to 700. Now, when I have seen them also, when they get around 700, have these strong, sharp peaks. And when that happens, we see an increased pressure on our Earth's shields, which are weakening, and they do each time we go into a solar minimum. But this is a grand cycle in the solar minimum, so things are going to be different. The weather's going to change. A lot of other things are going to change. Now, guys, I'm a little suspicious of that USGS map changing like that before my eyes, and so let's switch, and let's go to RSOEEDS. This has been a link on our website from, I think, day one, and down the center, just click on RSOE. Again, we're dealing with the Cascadia fault zone, and this is the ridge that I was concerned about. It looks just like the San Andreas, but underwater. Now, this is showing a different story. We've got a 5.2, 5.0, 5.0, 6.5, the 6.8 here on the ridge, guys, not off of the ridge at 10 kilometers. You see that? Now, if you go just north of there, it's showing the 6.5. Let's check the other ones out. 6.5. That looks like an echo. It's close, same magnitude, but these could be very fast aftershocks depending on the sensitivity of the way this thing's set up. Again, that's showing the 6.8. So these close ones could be, again, echoes coming through the range. I'm not sure what's going on with it, guys, but it's definitely showing more than those two quakes. And I want to just check the date and timestamp on these that are southwest of Peoria. December 8, 2.4. There's another one. 2.4, that may be the same one. Again, when they're that close together, the same quakes can be simply echoes. And I think that's what we're seeing there. But it does show that there's stress along that entire area. And we see these smaller quakes. This is not a usual formation. Pay attention to it, guys. It's a heads up. Be safe.